based wound dressing materials or silver based wound dressing material. And one thing I want to highlight here, that in India we don't have even a single product from our country itself which can be used for the chronic wounds. All the dressings we are using for the chronic wounds, we are actually exporting it from outside. All are either from US or Germany, Canada. We have few dressings from UK. So but all dressings which cost each dressing around 2000 3000 rupees, we are exporting, and we don't have our own product in this direction. So that is also one of the reason we want our made in India product, which by which we can actually save a lot of money for our country. So if it comes to clinical needs, what is the clinical need for ideal wound dressing? Ideal wound dressing, it should provide or maintain a moist wound environment. It should absorb the wound exudate. When there is a chronic wound, there is a lot of liquid coming out of the wound due to the which you call pus. So that exudate should be absorbed by the wound. There should be proper aeration, proper water, moisture on the wound. It should be maintained, and of course this dressing should prevent any kind of microbes to grow on it, because once there is an infection on the wound, that wound will not heal so easily. So we should have no infection on the wound. Thermal insulation should be there. The dressing should be cost effective. It should be biocompatible. Biocompatible, it is a very very important term. That means that the dressing, not only it should kill the bacteria, but it should not kill the skin cells. It should be safe for the skin cells. Now in this figure you can see what is the global demand in various kind of segments. So the demand for antimicrobial dressings is very very high. I think it is the maximum, that is 32.4%. So this is the commercially available dressings, as I have already mentioned, and most of them are either silver based or they are actually antibiotic based. I already mentioned you about this, and they are from US and other countries. And limitations of this antibiotic and silver based wound dressings. One thing I already mentioned, that antibiotic, it is creating antibiotic resistance. So that is very very important, and it is a major issue globally. Regarding the silver based dressings, silver also create resistance in the microbes, and some people, they have they are allergic to silver based dressing. This allergy, and silver also create some kind of staining on the wound. Means once you put these dressings on your wound, the wound will be healed, but there will be a brown color patch on the wound. There is a brown color of staining on your skin. So that is why researchers, they are actually searching for alternatives to replace these kind of dressings. Coming to the work in our lab, we are working on different aspects of antimicrobial materials and coatings. Like I mentioned, that antimicrobial for wound dressings, then contact lenses, dental implants, catheters, fabric, antimicrobial coatings on fabric, and antimicrobial films for food packaging materials. So different aspects we are working in this particular area. And in this presentation, I'm mainly focusing on the development of wound dressing, that how we are making in our lab. So basically, I'm focusing on one part of my work, starting from the from very simple material we are using, and then we are investigating for the animals, and then those dressings are right now in clinical trials. So from beginning to the end, the product level, I'm explaining each step, that how we initiated and how it actually right now in the clinical stage. So this is the electrospinning technique which we have used to design the materials. So electrospinning technique, it is a very simple technique. where what we do, this is a syringe. We basically take the polymer. For example, in this particular case, we are using gelatin, which is a protein for making the dressings. So we take the protein solution in this syringe, and below there is a collector plate where we are actually collecting these dressings. And between the needle and the collector, we are basically we are putting a very high potential. It is not high, it is very high. We are using around 13 kilovolts or 10 to 17 kilovolts, around in this range we are putting the potential. And when we put the potential, the solution which is coming out of the needle, because of that high potential, it stretch in the form of nanofibers. So basically, electrospinning technique people are using to design polymer nanofibers. So this is a different kind of setup people are using, because it has a lot of versatility. We can use single needle system, we can use multiple needle for bulk production. Then we have coaxial spinning, where we can use two polymers to make a bicomponent nanofibers, triaxial spinning for three component nanofibers, like that way. And this is different kind of setups we can use to design the nanofibers in different orientation. Also we can design, you can see here, this is basically the nanofibers, and different kind of gradient kind of nano spinning we can make. And this shows that what is the diameter of the nanofibers. So by electrospinning technique, we can design nanofibers from 1 nanometers to 100 micrometers. So a wide range of diameter we can design using the electrospinning technique. We can even design the nanofibers on non-conducting substrates like tissue paper, polyurethane sheets, bandage gauze. So different kind of substrate we can use to design the electrospun nanofibers. You can see these fibers. So this is basically the polyurethane nanofibers which we have designed using the electrospinning technique. And this is the biomaterial in the published paper where we have actually designed the nanofibers of gelatin. So this shows the versatility of this electrospinning, that what kind of material we can spin in the form of fibers using this technique. We can spin, the red color one are basically the biopolymers like gelatin, collagen, chitin. And this blue color, they are basically the synthetic polymers like polyurethane, polylactic acid, polycaprolacton, polyvinyl alcohol. So all these polymers also we can spin. In fact, we can spin small molecules like crown ether, cyclodextrin, even DNA molecule. So there are reports where people have actually spin the DNA nanofibers using the electrospinning technique. So it is very versatile technique. I just want to show a glimpse of it, if it will work, this video. Just one second. I think this video is not working, but basically it shows that how this electrospinning is going on. Is it visible?
Yes, ma'am, it's visible.
Visible.
Yes,
Okay. Okay, just one second. Yeah. Yeah. So this is basically a automated electrospinning machine. This is basically three needle system which is working. And here from the needles, the solution, polymer solution is coming. You can see this white color is basically, we are growing the nanofibers on a aluminum foil. So this white color is completely, nanofibers, and this is of gelatin basically. Yeah. So this is how the here are the syringes. The polymers are coming from these tubes.